Hi, in this tutorial I will be deploying an AWS EC2 instance by using Terraform infrastructure as a code. Before we start, to make it easy, we need to do a few things like I'm going to use a code editor like from Microsoft Visual Studio Code to write down the Terraform configuration files, the TF files. We need a Terraform tool installed on your machine. I'm using Amazon Linux EC2 instance, and this is where my Terraform is. Inside your machine, also create a Terraform folder. This is where we are going to save our configuration files. Use AWS IAM user, Identity and Access Management user. This user basically we are going to use to log in, not as a root user, but as an access and identity and access management user. Add the keys in the and SSH private key of your region in the terraform.tfvars file. This is where we're going to save the sensitive information there. We need also AMI or Amazon Machine Image ID. We are going to use either AWS Marketplace, or we just create our own EC2 instance, install and configure whatever service you want to be there, then create an image from that instance and use the AMI ID to add in your code. Transfer the TF files once you're done using Visual Studio Code application. Transfer these files to the Terraform folder you created where the Terraform tool existed. Important Terraform commands we are going to use for deployment, such as init. Terraform init command initialize a working directory containing Terraform configuration files. This is basically your first command to initialize. Then we are going to use a plan, Terraform plan command. It's like creating a execution plan. It's basically check if your configuration correct. It will show you what is like that the code that you wrote and the configuration you needed, without actually applying or deploying them. And then finally we are using Terraform apply command. Apply changes required to reach the desired state of the configuration. This is basically when you are ready, after planning everything out, you are going to deploy to provider. In our case, it's Amazon Web Services. Also, finally, if you want to destroy the infrastructure you just deployed, we are using commands such as terraform destroy to destroy the infrastructure. So here I'm using three main Terraform configuration files such as main.tf and variables.tf, terraform.tfvars. The main.tf, we are going to define the provider. It's Amazon Web Services, and you just write down the region and the IAM user access key and the secret key to log in as an IAM user. We are going to use resource such as virtual private cloud. This is the resource. We are defining internet gateway. We need public subnet as well. With this public subnet, we are using the subnet, route table association for the subnet. Also a resource such as AWS instance. This is defining my instance itself here. This instance also need a security group, so the web server security group. So in my case, I'm allowing incoming HTTP connections because this EC2 instance, or the AMI that I have, I also installed internet or web server. So ingress egress, I'm allowing HTTP port 80. So in my variables.tf, this is where to make it more to make the configurations more flexible and customized, we are using a hard-coded here, while in the main.tf we are using the variables to reference to the to this file. So I'm using a few variables here, such as AMI variables. This is my AMI ID, and the region US West 2. So this variable is the for virtual private clouds CIDR block. So this is my block for my virtual private cloud. Also the variables for public my public subnets, or the subnet I'm using for this EC2 instance. And here I'm using variables such as instant type. So basically, what is the type of your instance that you are deploying? In case here is the another configuration file, terraform.tfvars. Here I'm just putting my sensitive the sensitive information, such as access, secret key. These are the identity and access management user information, the key, the private key path in my region, and also the key name. Going back to the main.tf, we specify the provider first and the access details for this provider. We are going to access AWS. So the provider we call AWS, curly brackets, and we close the brackets. Inside we have the region and the information for our access identity and access management user. If you see here, they are variables values. They are not hard-coded values. So it's equal var dot and the name for the variable. Here is the name. If we go back and we're going to see these values are defined in our variables.tf or our terraform.tfvars. So in case of keys, these are the sensitives information. We put these values inside our terraform.tfvars. Here you see the access key and the secret key. These are the values that Terraform will be using to access the provider. And we see region var.aws_region. This is also a variable, and it's the value itself, it's in the variables.tf file. So if we go here, we are going to see that the value for AWS region is defined in the variables file, and we see default equal US West 2. So this is the Amazon Web Services region we are using. Now let's go to the virtual private cloud. We are writing down resource AWS_VPC space, and you just name the resource. So in my case it's technoconfig. You can write down whatever name you want here. Curly brackets open, and then in the block here we are defining the CIDR block. So it's also defined as a variable. So var.vpc_CIDR. If we go back to our variable here, we see that this is the value here, 10.0.0.0/16. So, and here it's variable value. So here we are writing down enable DNS hostname equal true, and also tags, if you want to use tags such as name to name this VPC, I'm calling them Terraform AWS VPC. Let's go to the internet gateway here. We have the resource we are using. It's Amazon Internet Gateway. The name, you call it wherever you want. Technoconfig IGW Internet Gateway. Open curly bracket and then close, and define your private virtual private cloud ID here. So AWS virtual private cloud dot the name dot ID, and this is referring to the virtual private cloud we just created. So you see here AWS underscore VPC, AWS underscore VPC. This is the resource, and you see the name for our virtual private cloud, technoconfig, and dot technoconfig, and then the ID. So this is ID for our virtual private cloud. So we are basically saying that this internet gateway should be inside this virtual private cloud. Going further, we need a public subnet for our EC2 instance for deployment. So the public subnet resource AWS underscore subnet, then call the name. This is the name. I just call it whatever you want. We define the block here, such as you need to define your virtual private cloud, where is the subnet will be located at. So the same, it's in the virtual private cloud and the name here for our private cloud. And also the CIDR block. It's a variable CIDR block, so var.public1 underscore subnet underscore CIDR. This is the name for the variable. So if we go here and check on the right side, we see the subnet CIDR. It's 10.0.0/24. So here, if you see it here, this is the name for the variable, and here's the hard-coded value, and this is the variable, the same name. Availability zone, we defining the zone, or the available zone here in our region. So it's 2B. And also tags, if you want to use tags, such as I'm using public subnet 1. Tags are also good for documentation and control over you, so you don't get confused. We also using a resource such as AWS Route Table, and this is the name for this route table. Again, we need to define the virtual private cloud, and this is the ID. We have the route, so it's CIDR block, everything default, and the target is the gateway. So this is the AWS, this is the resource name dot the name for the gateway. So this is the name you gave. So in my case, it's here, technoconfig IGW. It's the same name, dot ID. So on the route, you're saying that default route, everything, allow internet access, and the gateway is the target. Here we also have name. We are also need the resource such as AWS Route Table Association. This is and this is the name. We are adding the subnet ID here, our subnet. So this is the subnet, and this is the name for the subnet, public 1, which is we have here. This is our subnet we are using, and the route table ID we created on here. So it's AWS route table dot US West 2B public 1. So in our route table association, we need the subnet ID, and we need also the route table ID. Here we need to define this here, the resources, the instance itself, what type of instance you want. So if you have AMI, put your AMI ID here. Where do you want it to be? Availability zone. The instance type, the key name, and virtual private cloud security group ID. Also, we have something, the subnets, and whether we need public IP associated or not. We can, if you want it to be without public IP, you can define it as false. In my case, I need public IP, and the source disk check false. And you can call it, just name this EC2 instance. In my case, it's one server 2019, and I have web server on it. So in the AMI part, cool, I'm using lookup variable. So basically, it's saying that just look up for AMI, the AMI ID, in that region. So if you go back to variable file, we do have the region. So we are basically saying look up in this region, and this region has this AMI ID available. This AMI ID represents my Windows Server 2019 web server. So this is the one I created. So I used the lookup here. Availability zone, US West 2B. This is where the EC2 instance is going to use. The instance type, also I'm using variable, and this is the name instance type. Let's go and see it here in the variable.tf. As you see here, it's defined, and the value is defined here as t2.micro. You can use wherever instant type you are looking for. You have, I think, something like t2.small, whatever you want. In my case, for now, micro. Key name. Also look for the key name here. The key name in the tvar. If we go to the terraform.tfvars, this is the key name. This is our private key in that region. Security group. So, and this is basically the name, square bracket, and then $, curly bracket, and AWS security group, the resource.web.id. .web is your name. So if you go here, you will see AWS security group and the name of this security group we are using for our EC2 instance. We have subnet ID, and it's the name of the subnets we are trying to attach to this resource, to our instance. Associate public IP, we set true. We will see public IP IPv4 with our instance once it's deployed. We go to the security group. Here I do have, we are using a resource AWS security group, and the name is web. The description, here basically allowing incoming HTTP connection. So here we have ingress, egress, and ingress is basically just look at it like in and the E. So in is like inbound and E is like exit. It's like outbound. So inbound is oncoming and it's port 80. Set up the CIDR block to everything, and here also set up to everything, port 80. Also, if you want your EC2 to use SSH port 22, you can also allow this in the security group. Simply you can create another inbound rule here. You can create 22, and here also 22, and also for egress you can create an outbound, and here define it as 22, 22. Also, I want to talk about availability zone. So as you see here, it's hard-coded value. You can also customize this value and make it more flexible by referring to this value as variable. Simply we can define a new variable here. Let's say you want to make it go here and create a new variable. We can create one, and we can define this as availability zone. And this will be the variable name. The description will be the same. So we can call the description availability zone. Then we just write down the zone US West, and we can say to B. Now you can make it more flexible without hard-coded value on your main. So you can change basically this value to a variable instead of hard-coded values by writing down, let's say, like something like this. Copy and paste variable, and here we can put down the name of that variable. Copy and paste. So here, as you see, you have now availability zone is turned into a variable, and we defined that variable in the variables.tf. And also make sure to change this value wherever you see it. For example, you see it here, we can change that to the variable, the new one, and that should be it. So once you're done with your configuration files, save them and open a text editor in your Amazon Linux AMI in my case, and I will be copy paste in my Terraform folder. So the deployment should be in this part here, in the instances, once everything is successful on the Terraform. So let's head to my PuTTY, and here is my I'm inside the Terraform folder, and on my Amazon Linux AMI. And if I list the files here, I see 3 files, the main.tf, terraform.tfvars, and variables.tf. I will write command terraform init, the first command, and Terraform has been successfully initialized. Also, now we are going to check our work, our configuration. Terraform plan. So here we see if there's some errors. Everything look perfect. As you see here, the information is just showing you what the Terraform is going to do here. This is what Terraform will be create. And we can now test by running command terraform apply. This step should be the deployment for this infrastructure. And when it asks you for a value, click on just enter yes, enter. So it's going to take a few minutes to finish the deployment. Here says apply complete, resources says 7 added, 0 change, and 0 destroyed. Everything is successfully now. As you see, we have all the configuration that we ask for or we input in our configuration files. Going back to our AWS console, as you see here, the deployment is successful and we see our EC2 instance here. It's in my case it's Windows Server 2019 web server. I have web server installed on this Windows server. If this is the instance type, we configured t2.micro, the availability zone, and we do have public DNS and public IPv4 also. If we go back, services, virtual private cloud, let's see the configuration here. We also deploy virtual private cloud. This is the virtual private cloud, and this is the CIDR, exactly the same as we did. We do have subnets, the route table, and if you go here, we do have the local route table and the everything to the internet, and the target is the internet gateway, and this is our internet gateway attached, meaning that it's attached to our virtual private cloud. So I will be testing my web server if it's running. I will just basically copy the public DNS here, or if you want to copy your public IP, same thing, and from the browser you just paste and go. And as you see here, it's the web server is successfully up and running, and the deployment was successful without just the need to go to the AWS console and configure all these information step by step from the AWS console. I just basically write in configuration files with customized and flexible values, and with one command you just deploy, and also with one command you can just destroy everything. And this is the example of how it's effective, the use of infrastructure as code in the cloud. If you no longer need your Terraform infrastructure, you can destroy everything with one command. So by writing down Terraform destroy and hit enter. So now the Terraform will destroy all the infrastructure on your AWS. Enter a value, it's yes. Destroy completed. So going back to our AWS console, if you check here, you see it's now it says my EC2 instance terminated, means that it's done, destroyed by Terraform. Also the virtual private cloud, you can see that it's no longer here, even the subnets. That's it for this tutorial. I hope you enjoyed. Thank you for watching, and talk to you later. Bye.